Now that we've solved for inverse for tangent, let's solve for other trig functions. So let's solve secant squared of x minus 5 secant of x plus 4 equals 0. We can factor it to secant of x minus 4 and secant of x minus 1. So using the zero product property, we know secant of x is 4 and secant of x equals 1. Let's go ahead and change that. So the reciprocal of secant is cosine of x is a fourth, and cosine of x equals 1. So cosine of x equals 1 at 0, or we can say 2 pi. So x is 2n pi, or 2 pi n. And so that is our solutions for cosine of x equals 1. Now we have cosine of x equals a fourth. It isn't one of our values that we have memorized on a unit circle, so we're going to have to use something different. We're going to have to use arc cosine. So x equals arc cosine of 1/4, and cosine is positive in quadrant 1 and quadrant 4, so this arc cosine of 1/4 gets us our answer in quadrant 1. But cosine is also positive in one more quadrant, which is quadrant number 4. Now remember, with the inverse of cosine, we are restricted to a certain domain, because in order for a function to have an inverse, it has to pass the horizontal line test. And then, so for cosine, we had to restrict that domain from 0 to positive pi. Now, to get a better understanding of this and why this works, is let's look at a value that we do know. So let's say, when does cosine x equal 1/2? Cosine x equals a half in quadrant 1 and quadrant 4. Cosine x is a half at pi over 3, and then also it occurs again at 5 pi over 3. So what I want us to see is that the distance from the x-axis to our first angle is pi over 3, and because of reference angles, the distance from the same x-axis to our other angle, when cosine x is a half, is still pi over 3. Now we could solve for that by looking at our angles. So say, for instance, well, we know this is 2 pi. If we take the 2 pi minus the pi over 3, that should get us our angle of 5 pi over 3. So if you did do this, you would get 6 pi minus pi over 3. It's definitely 5 pi over 3. And so that always works. So therefore, in order to find the other angle that we need in quadrant 4, right, because cosine is positive at quadrant 1 and quadrant 4, then what we're going to do is we're going to take 2 pi and then subtract our arc cosine that we used, and that'll get us the other answer. So therefore, the second answer for cosine that we need is 2n pi minus the arc cosine of a fourth. And then, of course, we should add our 2n pi to get all solutions for cosine when cosine is positive a fourth. And so that is how you find the answers using inverse for cosine. So try this example here. Solve when secant squared of x plus 3 secant of x minus 10 equals 0. If you solve for it, you should have gotten secant of x plus 5 times secant of x minus 2 equals 0. So we get secant x equals negative 5 and secant x equals 2. Find the reciprocal. Cosine of x is negative 1/5. Cosine of x is a half. Cosine of x is a half, we actually did that earlier, is at pi over 3 and 5 pi over 3, and it's asking for all solutions. So we add the 2n pi, or 2 pi n, to each of those to get all of our solutions. Then we have to use inverse of cosine of x equals negative a fifth. So x equals cosine inverse of negative a fifth plus 2n pi. So that gets us our answer in quadrant 2. Then to get the answer in quadrant 3, we take 2n pi minus our arc cosine of negative a fifth, and that is the solution for this problem.